Hi everybody, in today's omarvision tutorial, I'm going to do another tutorial on neural networks, artificial intelligence, using the MLAgents library in Unity. So I really want to make a racing game where the other cars on the track drive around the track using a neural network to control their driving. So I'm trying to figure out how to do this. So what I first did was I set up kind of like a road here, and I put some cars. I put a car, and then I just made a copy of the car so that the training could happen faster. And the car basically has there's the blue body of the car, and then there's the four wheels on the car, which are separate. And at first I did it like that because I thought that the wheels would touch the terrain, and then when the car body touched the terrain, then that could be detected as like, okay, it banged into the wall. So reset and start another training episode. That wasn't working out because I guess since the wheels were a child of the car body, the collision from the wheels was carrying up to the car body, and it just wasn't detecting the terrain collisions. It just wasn't doing it. Maybe it was a problem in the code. But anyway, what I did just to make everything simpler was I put these barriers here. So if the car bumps into a barrier, the training episode fails and it starts again. These walls here, they are the checkpoints. When a car hits a checkpoint, it basically is going into the right direction. It's a target for the car to drive in to pass through the checkpoints as it follows down the road. Okay, so that leads me to explain the objects. This is the terrain, and I just dug out a path in it. Just figured that's the easiest way to make like a road of some type. Then I have the checkpoints, which are these walls highlighted in blue. See, so I have 4 of them, marking out the path. And then I put these barriers here to keep the car on the track. All right, so to do a project using MLAgents, you have to have the package installed. So here from the Windows Package Manager, when I created this project, I used the Package Manager and I made sure that I had the MLAgents package installed. So these are the ones in my project. And I made sure I had MLAgents. The other thing when you're doing neural networks with Unity, other than having the MLAgent Unity package, you actually have to have MLAgents installed on your system. So I have a video on how to do that, but this is my MLAgents window here. It's a command window. And to see how to set up MLAgents to do a project like this, you could just go to my YouTube channel, omarvision, and just do a search here real quick for MLAgents. And then here's an install and setup. And then I have another one. Where is it? Here's another one that's even shorter. Set up MLAgents for Unity. This one's a 5-minute video on how to do it. Okay. So I have my 3D project with the MLAgent package, and I have my MLAgents installed on my system, and I have Anaconda installed so I could run the MLAgents on my system. Now, what did I do for the code for the car, which this is the little artificial intelligent agent, the car. There's a script I created for it. It's the car agent script. So let's take a look at that. And here it is. It's using MLAgents from the Unity thing. And when I put this on, I just had to make sure I had a rigid body and an MLAgent decision requester object on my game object. So instead of deriving off of mono behavior, I derive off of agent. And agent still has all the methods of mono behavior. It's just that it has additional methods, like these ones here that I'm overriding. And these additional methods interface with the MLAgent library. Anyway, so for my car, I have a move speed, a turn speed, then I have a pointer to the rigid body, and then I have a recall for the position and the rotation of my car, so that after each episode, if it succeeds or fails, when it starts the next episode, it could just reset its position and like kind of reset the whole scenario. Then as I'm going through, I kind of wanted to know what the current wall is that I'm aiming at. So like over here, this wall here, this is wall 0, this is wall 1. So over here, I just set it up that I have a variable, a string that names the current wall that the car is going to try to hit. And then I have a pointer to the checkpoint script. So these like checkpoints over here, these walls, I just have a script for those. And this script is going to basically just tell me, it just basically gets all those walls into an array. And, it has the thing where it draws the line between the walls over here, the gizmos. It draws the lines like between the walls and then loops back with the blue line back to the first wall. And that's what the on-drawer gizmos is doing. And then the walls have names, right? Each of the walls have a name. And you could see over here that I named the walls like wall 0, 1, 2, and 3. And that way I could tell which wall's next by the number. And what I do is I extract the number from the name with this little regular expression here. And then when my car script, over here, my car script, the car agent script, and it wants to know what the next wall is, it could just call the checkpoint script get next checkpoint name. I pass it in my current wall name, like wall 1, and then it would extract the 1 and add to that and be like, okay, is it 2? Do I have a wall 2? If not, then I loop back to wall 0. And then it just returns the new name. So that's what the checkpoint script is here doing. And back to the car script over here. Initialize. Initialize is what happens when your game starts. So it's like the start command of model behavior. Initialize is like the start command, but works with the agent class. So here I get a pointer to my rigid body of my car. I get a pointer to the checkpoint script of my scene. See, so here's the checkpoints game object. And on that, I have the checkpoint script. So I could, call the checkpoint script function to get next checkpoint. And then I store what the position and the rotation is of this particular car. See, so each car has a starting position that I put them in. It gets that position and stores them. So that's the initialize function. It happens when the game starts. Then also, after the game starts, the first episode will begin. So on the first episode, when the episodes begin, I set the positions and I set what the first wall is going to be. The first wall target is going to be this wall, which is wall 1. Yep, wall 1. So that's what happens when the episode begins. Then now that the episode begins, when I press play, if I have the MLAgent library running to train the neural network, and I press play in Unity, the training begins. And what's going to happen is the MLAgent library is going to be giving random instructions, random actions to the car agent. How many actions they are and what each of those actions say to do is determined by this behavior parameters component. When I dragged and dropped the car agent script onto the car, the behavior parameters component got added, the decision requester component got added, and the rigid body component got added. So those 3 things, as well as the car script, were put there. The behavior parameters component is basically describing the neural network for the car. So I give it a name, car agent. That's going to be the name I give my neural network. So when I do the training process, the MLAgent library is going to create a neural network file, and the extension of that is ONNX, and the results go in here. And here's where it puts all the training files. Here's the latest one. Okay, so now we go back to the car. So that's where it gets the name for that. The vector observation, these are the when you have a neural network, let me bring up a picture of that. Neural network. Neural network. Okay, so you can just see a picture of neural network. It basically has the inputs. These will be the vector observations. Then there's the neural network in the middle that plays around with all the values. And then there's the output of what it's going to do. So the neural network, it doesn't know anything about the car. It just has values that come in. The values get played around with, and then it makes values that come out. It's basically that simple, right? That's all the neural network knows about. It doesn't know anything about me being a car. So here, the vector observation, that's how many values are coming in. So since I'm using the ray perception sensor, I could leave the vector observation space size as a 1. And then the ray perception sensor will take care of setting the observation space. See, because I have so many rays here, and the rays have so many values. So when I use the ray perception sensor, I could just leave the vector observation space alone, leave it at 1, the default. Now the vector action, these are the values that are coming out of the neural network. These are the values on this side, the actions, right? So I could say, what kind of values do I want those to be? Do I want those to be discrete whole numbers? Or do I want them to be continuous values, like from 0 to 1, or from -1 to 1? like with all the little decimal values in between. So here for the car, I picked discrete to have whole number values. And there's going to be two action nodes, okay? So here in the picture, it's kind of like there's two action nodes over here. But for each node, what are the values that will be acceptable? So that's where, oops, let me come back to Uni. That's where the branch size comes into play. So I have two nodes that are coming out of my neural network. And there's 3 values for the first node and 3 values for the second node. So that's what this size means. Okay. Then the decision requester, that's how many times I'm going to ask the MLAgent library, the neural network. That's how many times I'm going to ask for the neural network to decide something for me. So basically, the lower the number, the more decisioning the brain's going to do. And then here's the ray perception sensor. It's just a nice component you could put on your object. And then I could just set the rays like to look out. As you can see, they're looking out over here. And I could just control that with these values here. Like I could have more rays or less rays. And what did I have it at? 6, I think? 6. And then the ray degrees, that's at 180, right? Well, I could have them all pointing to the front or pointing all around or pointing, you know. So I had it at 180, so it's like all around. Then the length of the rays, like how far do they look? How far do they look out? It's set to 20, but, you know, it could, let's say if it was like 5, you know, then the rays only look this far. Anything further than 5, it can't see. But, you know, I had it set to 20. And now this is what the rays are going to look at. So for every game object here, like the barriers and stuff like that, I put them on the layer of obstacles, things that my agent is going to be looking for. I put them all on one layer together. I put the barriers on the obstacle, I put the walls on the obstacle layer, and did I put cars on that? No. Okay, I didn't. But here in the ray perception sensor, I could, so that the rays like kind of shoot through the cars or wheels or other things on there and go to the things it's going to see, I put them on obstacles layer. And then here, these are the things that the raycasts are going to detect, that they're going to pick up information for when they hit. It's going to pick up information for anything tagged as a barrier. And you can see this here, I tagged that as a barrier. And it's going to pick up for anything tagged as a checkpoint, like this over here. So here I have barrier, checkpoint, and then I also made it detect if it hits a car. So, car. Okay. And stacked raycast, that means over time. So since the car is going to be a moving object, and as it moves, I want the neural network to get a sense of a direction the car's going in. If it only had one set of raycast at a time that I was looking at, it can't tell which way it's going. It's only one instant in time. So I just gave it a 3. So it could look at in time of 3. And these offsets are basically like in the beginning, the raycast starts from high or low. And then the other one at the end is like if it goes up or down for when it's looking. Okay, so that's what those are. So this ray perception sensor is pretty cool for automatically just having your object look around. Now for the important part, how do I decide how to reward or punish my agent as it's going around doing all these random movements? The rewards and punishments that I set on the car agent script are going to basically guide the training of this car to behave a certain way. Remember, before I get to that adding rewards and stuff, remember there's 2 values that come out over here. What do I do with those 2 values and how do they control the car? That is done by taking the onActionReceived method of the agent class. And this vector action, these are my 2 values that are coming out that I had set in my script, in my component, the behavior parameter component. I said the branch size is 2, and I said that I want 3 values on the first branch and 3 values possible on the second branch. And this is my interpretation of what I'm going to do with those values that come out, those whole number values. So if the neural network, you know, processes its observations and comes out with the vector action of 0 on the first node to be the value of 0, I'll move my car backwards. If the value is 1, then I won't move my car. And if the value is 2, then I move my car forward. Okay, so my first node output node of my neural network, I'm going to use it to move the car. Okay, now to encourage the car to move To not move backward, I want the car to go forward. It's a race. I really want it to be going forward. So if it goes backwards, I kind of give it a little bit of a punishment, you know? And then if it goes and it's not moving at all, I definitely don't want the car to just be sitting there. So I give it a bit of a bigger punishment than this. And these numbers I had to play around with, but basically I made it that my reward of 1 is like my highest reward, and my punishment of -1 was my biggest punishment, and I kind of worked with that. Now what I wanted to do is move forward. So these were punishments, the values are negative. If there's something I want the neural network to learn to do, I give it a positive value. So this forward has a very small positive value because, as the car is driving around the track, it's going to get a lot of rewards, if it's once it starts learning to move forward. But I just wanted to encourage it to move forward. So here I give it a little bit of a value. So that's all about the movement of the car, the control of the car, and the rewards and punishments for that. There's another control of the car other than movement, and that's the car's turning, steering to the left or the right. So on the second node, that's what I did. On the second node, I used that to determine if I turn left or right. See, so here are the values 0, 1, and 2. Turn left, don't do anything, or turn right. So the same thing, when the whole number of values come out on vector action 1, 0 is left, 1 is don't do anything, and 2 is turn right. And turning left or right, I didn't give punishments or rewards because, it's just going to have to figure out when does it have to turn left or when does it have to turn right, and I don't know if it's right or wrong. Okay, so that's that. Now there's things here, I'm adding rewards, and I'm punishing with rewards, but when do I stop an episode and start a new one? When do I say, okay, this car was doing something, it failed, or this car was doing something and it succeeded? So I say that if the car is driving around and it hit the barrier, it fails, start over again. If the car is driving around and it hits the checkpoint in front, in this training, I'm only going to move to the first checkpoint, then the car succeeded. Whoopee, you won. Okay? And start another episode and see if you could win again. So where do I do that ending of an episode? I do it on the collisions and the triggers. So the wall is a trigger. The checkpoint wall is a trigger because, I want the car to actually drive through it. So I had to set it as a trigger so it could move through the wall. And here I see if I have a trigger from a checkpoint, a wall. If that's true, then next thing I have to do is like, okay, is this the wall that I'm supposed to hit? Because there's a wall behind me and in front of me. There's walls all over the place, right? But this car right here, the wall it has to hit here is this one. And then it will hit the next one. So you see there's a wall behind it. So if this car is driving around, I want it to go forward and go this way. If the car is driving around and hits this wall, that's not the wall I want it to hit. It has to hit this wall. So I check the name of the wall. And if it happens, great. Then I add the reward of 1. That's my biggest reward that I'm going to be giving out. And I end the episode in this simple training scenario. I end the episode. I just want to make sure if I could hit this first wall. And then the collision with the barriers, I also want to end the episode. So the barrier is an object I can't drive through, but if I hit one and I crash into a barrier, instead of using a trigger to pass through, I use a collision. You hit it and you don't pass through. So here the collision with a barrier is true. Then I punish it, -1, and I end the episode. Okay, so I have 2 ways to end my episodes. I have a success way over here that you hit the checkpoint, and over here I have a fail if you hit the barrier. So with these 2 things, with a success and end the episode and a fail end the episode, that's probably enough, the bare minimum that I have to do the training of the neural network. But then here I just added some additional things because I didn't want the car to learn how to go backwards and go through the walls. I wanted the car to learn how to drive forward through the wall. So I kind of added rewards for going forward and punishment for going backward to have the car go through the wall forward. And that was like through trial and error that I figured that out. So if I wanted to start the training, I go into my MLAgent window with the Anaconda software that was installed here. And here at the command prompt, I type MLAgents learn. And then I've done the training before, so I could say force to overwrite the last brain that I used, or I could do a training and just use a new name for a new brain. So I could say run and give it an ID equals car agent 2 for my second brain instead of car agent. This could be car agent 2, and I think it was spelled with capital, so I'll just keep it the same, car agent 2. Okay, and then from here I would press enter, And this is going to start up the MLAgent library. Okay, you see the Unity symbol, and then it says it's listening on port 5004. That's how it communicates with Unity, through this port. All right, so now back in Unity, I have my 3 cars. So first let me make sure the cars are not using a brain. So I'm going to select my 3 cars. And here on the behavior parameters, I see that I'm using a brain. What I want to do is not use a brain, so it's going to train instead. And now I'll press play, and then the training is going to begin. So it takes a while to start. And here it goes, it starts. And one of the things I should see, I see sometimes they're moving backwards. When the training is running, it does run at a higher speed than naturally. So as you see, the cars are like moving around, they move around, and they're figuring out it's getting rewarded or punished. And the neural network's figuring out how to move forward. Like, see this car, it's hitting the wall, it's doing its job. This car hit the barrier, it comes back. But sooner or later, all 3 cars are training on the same brain. The brain is going to learn how to move the car forward to hit the wall. So as that's happening, here in the MLAgent window where I ran the command to start it, it starts off by telling me what were the parameters for the neural network. It just shows them right here, the parameters that are being used. And as the training happens, it'll kind of give me these progress updates that would show in the window. And it takes a while for the first progress update to show, because I think it waits for like 5,000 episodes or something like that. And it'll take a while for me to get that first training parameter. But if I want to stop the training ahead of time, like if I want to stop it right now, I stop it. Then when I stop it, the MLAgent library will output the car agent 2, the ID that I gave it. It'll output the neural network file, ONNX. Okay, now it outputted that file right here in the results folder. Now if I want a car to use that, I could just pick one of the cars, right? And then I could go here on that car's behavior parameters component, and I could pick, where's car agent 2? I'm not sure, sorry, but one of these is, this is PPO car agent, and this is car agent 2. Okay, so here's car agent 2. I'm going to use that one because it's in the folder here for car agent 2. So what car was that I did that with? So one of these cars has a brain, the other 2 don't. Now I put the brain that just got trained on this car. It was a very short training. Now if I press play, we'll see what that car does. The other 2 cars should just sit there because they don't have a brain, and I'm not running the library. And you can see this car with its brain is driving to the wall. It learned how to drive to the wall in a very short amount of time. So that is the goal of me training this car to turn and drive toward the wall. These other 2 cars aren't moving. Now, setting up this scenario, as I call it, to do this training, it takes some precision. It takes careful consideration. Like, how did I know that I had to put these barriers here and I couldn't trust the car to bang into the walls of the terrain? How did I know and make sure that the car was detecting the collision with the trigger? How did I know that the actions were actually going to move the car in the right direction? There's a special function I could override in the agent class to manually control the car, to let myself be the brain for the car. And that's the heuristic function. So here's the 3 cars, and they're not running off of the brain. They're going to run off of me moving with my fingers. See, so I could press forward, backward, then I could turn to the left, and I could turn to the right for these 3 cars. And they kind of do what I say. Okay, they turn left and right. So one, I'm making sure that the control to turn left and right works. Then I make sure the control to go backwards and forward works. And I'm making sure manually that when I touch the barrier, that it resets and it starts another episode when it touches the barrier. And I make sure that when it touches the checkpoint wall, that it goes ahead and it starts another episode. I could also make sure that when it touches the wrong checkpoint wall here at the bottom, that it doesn't. So I could do the testing to make sure I have everything set up right before I start doing the training. And that's very important, Because sometimes you'll be training and you're wondering like, hey, why haven't there been any episodes completed? Or you'll be doing the training and wondering, why isn't anything getting any smarter? Why aren't the results for the reward amounts getting any higher? Because they usually start off at like point 0. And then like if you get like 0.9, that's pretty much like a super well-trained brain. And then you could stop the training anywhere in the middle if you don't want your car to be that smart. If you wanted to make mistakes, you could stop the training at 0.5 or something, or 0.4, you decide. And that's some of the benefits. But anyway, with this scenario, with this training of me trying to train the cars to move through all the checkpoints, my first step was just to get the cars to move toward the first checkpoint. And I'm going to stop this tutorial right here. And in my next tutorial, I'll try to get the cars after they hit the first checkpoint to go to the next one and the next one to go all the way down this road. Okay? But for now, this is where I'm going to stop. And I'll have the code on my GitHub channel, which will be in the comments. You could click the link to get the source code and try this thing out yourself. All right, thanks everybody. Have fun.